Hello my dear friends. Today I want to discuss about casting process. So casting is one of the oldest manufacturing process and even today is the first step in manufacturing process is casting. In this process the material is first liquefied by properly heating in a suitable furnace. Then the liquid is poured into a previously prepared mold cavity where it is allowed to solidify. Subsequently, the product is taken out of the mold cavity, then trimmed, then clean the outer surface and desired shape will come. So this is all about casting process. So it is clear from the definition the process that a successful casting operation needs a knowledge in the following areas. Number one, preparation of mold and pattern. Number two, melting and pouring the liquefied metal. Number three, solidification and further cooling at room temperature. Last one is identification of defect and inspection of the product. So this is basic idea of a casting process. So now, what is our objective? Course objective is to identify and select proper manufacturing process for a specific component. So in my whole lecture, these 5 topics I will cover. So this thing I have said just now. So now, what is the history of casting? This. If you see that, just go through. Now question comes, why casting? I ask 3 points. A job of 5-meter diameter and 10-meter length. A job with a hole of 2-meter diameter, made of very hard material, parts of very complicated shape. So which type of machining process or which type of manufacturing process I have choose? No other option, only one option is casting. So have you seen any similar process before? This shape and size of the cavity of the mold, mixture composition, temperature, cooling time, carefully remove it. All of you, I think, see in your household purpose also. So now, what is the requirement of casting? Cavity of desired shape mold, molten metal, proper channel to fill the molten metal. So what is the basic step of casting process? 1/2 of the pattern, flux placed over the first pattern, 1/2 of the mold, this is called cope, 1/2 of the pattern, this is flux placed over the second pattern, 1/2 of the mold that's been dragged, assemble it, casting through the gating system, and after that solidify the casting. So some basic term is there in casting. Number one is pattern. This is a replica of a desired part. Then mold, container with a cavity within divided in 2 parts. One is cope and another is drag. Upper portion is cope, lower portion is drag. D for down, that's why drag. Keep in your mind. Gating system, network of a channel that deliver molten metal to the cavity. So what is the basic step? First step is pattern making, then mold making, then melting a metal and pouring, then cooling and solidify of the metal, then cleaning of casting and inspection. Then I discuss pattern. This is basically replica of a desired product. A pattern is a replica of a part to be cast and is used to prepare the mold cavity. Has somewhat different dimension than the actual part to be manufactured because some allowances will be there. Used to form the mold cavity. Material used, types of pattern and pattern allowances I discuss one by one. Pattern material. What is the requirement basically? Easily shaped, work and machine and join, resistance to wear and corrosion, resistance to chemical action, dimensional stability, easily available and economical. This is the basic requirement when you select any pattern material. Suppose wood. This is basically easily available, can be easily shaped. More than 90% casting used wood pattern, absorb moisture, relatively lower life, etc. Metal used for large quantity production, closer dimensional tolerance, longer life. Aluminium is mostly used. Other metal can be used, maybe cast iron, brass, etc. Plastic, lightweight or low weight, easier formability, smooth surface, durability, do not disturb moisture, absorb moisture. So dimensional stability is more, corrosion resistance, etc. Polystyrene, change to gaseous state on heating, disposal pattern and suitable for single casting. When molten metal is poured into the cavity, polystyrene transformed to gaseous state, used mostly for small and complicated shape casting. Now, different types of pattern I have discussed here. Single piece pattern. This is with the help of diagram. You will see that used for simple shape and large casting. Pattern and cavity produced by it for completely in the lower flux cause difficulty in the making the mold. Split pattern. Split pattern molds that part as two separate pieces that meet along the parting line in the mold. Two parts are aligned by double pin. Loose piece pattern. As per the name, pattern contain one or more than one loose piece. Loose piece is used to make removal and pattern easy from mold box. Loose pieces are attached to maintain body with the help of double pin or wire. First main pattern is drawn and then carefully loose piece. Molding with his pattern is expensive and require more skill. Match plate pattern. Simpler to split pattern. Expect that each half of pattern is attached to opposite side of the single plate. Match plate confirm the parting line. Ensure proper alignment of the mold cavity in the cope and drag and runner system can be included on the match plate. Used for large production quantities. IC engine piston is produced by this match plate pattern. Cope and drag pattern. It is similar to split pattern. Each half of the pattern is attached to a separate plate and the mold halves are made independently. Pattern is made in two halves and split along parting line. These two halves are known as cope and drag. Their molding done independently. After molding, they are assembled to form complete mold box, often desirable or large casting. Gate pattern. In this pattern of gate and riser or runner are permanently attached to the regular pattern. They are used to manufacture multiple casting on time. Each pattern is connected with common runner suitable for pouring small casting and for mass production also. It saves labor and time. Pattern allowances. So many allowances is there and consider of allowances is much important. Shrinkage and contraction allowances, draft or taper allowances, machining or finishing allowances, restoration or chamfer allowances, wrapping allowances, etc. Shrinkage allowances. If a material, but when a material is solidified, some shrinkage is take place. So one is liquid shrinkage, another is solid shrinkage. Liquid shrinkage, when liquidify material, some shrinkage is there. When metal is solidified, some shrinkage is there. This is some consideration. Shrinkage allowance. Shrinkage means contraction of metal on solidify. All metals shrink after solidification. It is expressed in millimeter per meter. Shrinkage allowances differ from material to material. Positive types of allowances. Some chart is there. Draft or taper allowance. Taper provided by the pattern maker on all vertical surface on the pattern so that it can remove from the sand without tearing away the side of the sand mold. Inner details of pattern require higher draft than outer surface. Commonly applied draft allowances 1 inch to 1 degree to 3 degree. Due to draft allowances, pattern can easily remove from the mold box. Draft or taper allowances. The length of the vertical side of the pattern are extracted. Intricacy of the pattern, the method of molding, pattern material, etc. Machining or finishing. The finishing and accuracy in sand casting is generally poor. So extra material provided on the casting to enable their machining or finishing to require size, accuracy and surface finish. This is the chart. Distortion or chamfer allowances. Due to their typical shape, casting get distorted after certifying. Distortion is observed in irregular casting so that it shrink uneven manner. Distortion are caused by internal stresses which are generated on account and unequal cooling of different section of casting. To avoid the distortion, allowance is provided. It varies from 2 to 20 mm. Wrapping or shaking allowances. Before withdrawal from the sand mold, the pattern is wrapped all around and vertical face to enlarge the mold cavity slightly, which facilitates its removal. When pattern is wrapped or mold cavity is enlarged, to account this increase, pattern size is reduced. These allowances is important in large casting and precision casting also. Some product made by casting. This is example of casting product. Some advantage. What is the advantage? Complex form, low cost, certain shape cannot be machined, one piece part versus multiple piece part, design change are easily incorporated, high volume, low skill labor, large and heavy part can be made easily. Some disadvantage also there. Problem with internal porosity, dimensional variation due to shrinkage, trapped impurity, solid and gases, high tolerance, smooth surface not possible, more costly than stamping or extruded in some cases. So these are all about basic introduction about casting process. So if you have any query and any doubt, feel free call me and email me. Thank you.